Welcome back, Algebra 1. We are actually in our last video for factoring, so yay us. After this, we're just going to do a lot of review and make sure you guys really understand it. But yeah, this is our last section for Chapter 8, and then we will have some type of test on it. So I'll give you guys more information over the next couple of weeks and everything. So our last section here is going to be 8.7 factoring special products. So none of this is going to be really like super new, but a lot of this is going to be just like basically special trinomials and binomials that are important and really that you do need to know. So we're going to start off with basically just like a little bit of practice of what you already know how to do, and that's going to be with perfect square trinomials. Now we have talked, I know you probably don't remember, but we have talked about what a perfect square trinomial is when we were in class. I know it feels like eons ago. So perfect square trinomials. So what a perfect square trinomial is, and we are going to factor, and I'll show you. So a perfect square trinomial is like this: x squared plus 8x plus 16. So a perfect square trinomial, what that means is the numbers both on the outside are perfect squares. So 1 is a perfect square, 16 is a perfect square. And that's essentially what a perfect square trinomial is. Now, if you guys are like, I got this, I feel so comfortable with factoring now after watching all of the videos, great. If not, then, we're going to still go over it together. But if you guys want to pause me here and try this one on your own, that's totally fine. Okay, so we're going to start with the big X. The number that goes on top is always that 1. Well, not just always 1, but that number that's in front, which in this case it's 1. 1 times 16, so just 16. And then my base, my bottom is my B. So I'm thinking what two numbers multiply together to get me 16 and add to get me 8. Now, in the name, it's kind of like an indicator. 16 is a perfect square. 1 is a perfect square. And what is the square root of 16? Well, the square root of 16 is 4, and 4 plus 4 is 8. So this is a perfect square trinomial. So remember, you guys can use the shortcut here, but if you're still feeling comfortable with splitting the middle term, you can. So if you want to split the middle term, you can. If not, you can go straight to the shortcut, x plus 4 times x plus 4. So remember, I only went straight here. I can only use the shortcut. So only use the shortcut when a equals 1. Other than that, you've got to split the middle term. Now, okay, so x plus 4 and x plus 4, we have a special way of writing that. Now, if you wrote it like that, I'm not going to mark you down. That's not something that's overly upsetting for me. But the appropriate and more proper way to write that, because there's two of the same things, we write it as x plus 4 squared. Because x plus 4 squared means we multiply x plus 4 by x plus 4 twice. And so that is the mathematically correct way of writing it. And that is one of our perfect square trinomials. So we're going to do another one, and I'm just going to get my paper in half there because, I like it to be neat. And so then we are going to go to 2. And we're going to do another perfect square trinomial. So it's going to be 4x squared plus 12x plus 9. Okay, so a is not equal to 1 in this one, so we can't use that shortcut. But our setup doesn't change. If you guys want to go ahead and pause me and do this one on your own, great. If you want to keep going with me, that's fine too. So on top is going to be 4 times 9. 4 times 9 is 36. And then b is 12. Okay, so if you notice, again, 4 is a perfect square, 9 is a perfect square, and 12, well, what's the square root of 4? Is 2. What's the square root of 9? 3. 2 times 3 is 6, and 6 plus 6 is 12. So what are my two numbers that multiply together to get me 36 and add to get me 12? Well, it's 6 and 6. Now this one, I do have to split the middle term, but you can see sometimes with these that there is a little bit of a shortcut with these two, but only with perfect square trinomials. So I'm going to split the middle term here. 4x squared stays the same. And then obviously this really doesn't matter because they're the same. So 6x plus 6x plus 9. And then we factor by grouping. So 4x squared plus 6x is one of my groups, and 6x plus 9 is another. So what can I factor out of 4x squared and 6x? So I know it's not 4, so I've got to think smaller than that. I know it's going to be 2. And then they both have an x, so it's going to be 2x. So 4x squared divided by 2x is 2x. And 6x divided by 2x is 3. I always bring my sign down. And then I think what divides by 6x and 9? And I know it's not 6, so I have to go smaller. So I think 3. So 6x divided by 3 is 2x, and 9 divided by 3 is 3. Now remember, these have to be the same, which they are, 2x plus 3 and 2x plus 3. So that's one of my factors. And then what's left? Well, what's left is also 2x plus 3. And so again, we get that perfect square trinomial where it ends up to be the same two factors. And so we write it as 2x plus 3 squared. So if you were to know, like by just looking at this, that this was a perfect square trinomial, then you could go from here to here. And how can you do that? Well, we know the square root of 4 is 2. Or actually, let's be more thorough there. We know the square root of 4x squared is 2x. And we know the square root of 9 is 3. So that's that. So that's perfect square trinomials. We are going to do a little bit of a review here for before we dive into the next one. It's just going to be 2 multiplying problems, but we're going to kind of go in between with a review. So you're going to multiply these together. So first one we're going to multiply is going to be x plus 4 and x minus 4. And then over here, I'm going to have you guys multiply 2a plus 3b times 2a minus 3b. Okay, so pause here, multiply those on your own, and then we'll come back together and talk about why we're talking about these. So you should be pausing, you should be multiplying, use your box method, whatever method you're going to use, and then come back. Okay, so hopefully you're back from multiplying, you have your answer. And when you multiplied, you got x squared minus 4x plus 4x minus 16. And so what happened to the middle terms? Well, the middle terms, negative 4x plus 4x is 0. And so I have x squared minus 16. The middle terms canceled out. And with this one, okay, so that's 4a squared minus 6ab plus 6ab minus 9b squared. Well, what happened again is the middle term canceled out, and we're left with 4a squared minus 9b squared. Now, what these are called difference of squares. Now, notice in both factors that they're almost the same. Just like up here, they are the exact same. But what's different are the signs. So one is plus, one is minus. One is plus, one is minus. And so what these are called is difference of squares. And so we're going to actually do that. So difference of squares. Now, the reason why we call them difference of squares is really like because of what's in the, like it's in the name. So both of these are difference of squares. And the reason these are difference of squares, so what makes something a difference of squares is your resulting product. So the resulting product is going to be two terms, 1, 2, 1, 2. There's subtracting between the terms. So there's subtracting, which is why we say difference. And then both terms are perfect squared. X squared is a perfect square, 16 is a perfect square, 4a squared is a perfect square, and 9b squared is a perfect square. So all terms are perfect squares. Now we can still actually apply what we know to these types of problems, but you can also kind of use like a rule. So I'm going to show you the rule, and then I'm going to also show you, I'll show you the rule after. What I'm going to do is I'm going to just get into some examples. So I don't know if I should start with 1 or 2, but I'm going to start with 3 actually. I'm going to be going from the next blue. I don't know. Okay, so my first one that I'm going to ask you guys to factor is x squared minus 64. Now, I told you guys that we can kind of think about this as the same way that we have been. Now, like there isn't 3 terms here, but I can think about this in terms of like it being 3 terms. Because my middle term, there isn't a middle term. So instead of writing something, what I can do is say plus 0x minus 64. And now I have something just like we've done in the prior videos when we have 3 terms. I can set up a big X. On top is going to be 1 times negative 64, which is just negative 64. And on bottom is going to be that B term, which is 0. And so I'm thinking what 2 numbers multiply together to get me negative 64 and add to get me 0. Now, hopefully you're thinking, we know the square root of 64 is 8. And so it's a positive 8 and a negative 8. So 8 times negative 8 is negative 64, and 8 plus negative 8 is 0. So we can then go straight to the shortcut. We can go to the shortcut because a is equal to 1, and I can go x plus 8, x minus 8. And that would be my final answer. Now, let's say you had, let's try a different one. Okay, we're going to do 4. So what about x squared minus 100? So if you guys feel good after 3, try 4 on your own. If you guys need my help, that's fine. But pause me here, try it on your own. Do as much as you can on your own, and then come back. So I always encourage you guys to always do that. Okay. So you can rewrite it if you want as x squared, but I'm going to show you the shortcut in a second. Plus 0x minus 100. So if you want, you can set up that x on top is 1 times negative 100, which is just negative 100. And on bottom is my b term, which in this case is 0. So I'm thinking what 2 numbers multiply together to get me negative 100 and add to get me 0? Well, we know it's a perfect square, so I'm thinking first, what about 10 and negative 10? And that's the case. Now, again, a is equal to 1, so I can use the shortcut. X plus 10, x minus 10. And that's my final answer. So there is like a shortcut with all difference of squares, but the biggest thing is knowing that something is a difference of squares. So if you recognize that like all of these 4, x squared minus 16, 4a squared minus 9b squared, x squared minus 64, and x squared minus 100, those are all perfect squares. So again, to make it a perfect or a difference of squares, it would be 2 terms. They have to be subtracting in between, and both terms have to be perfect squares. So there is a shortcut. There's kind of a rule. So I'm going to write that rule. So to factor a difference of squares, use the following rule. Okay, so if I have a squared minus b squared, so 2 terms, they're subtracting in between. A is a perfect square, b is a perfect square. We can factor it to be a plus b and a minus b. So that is our rule. So notice, and I'm going to circle back to kind of the ones that we've already done. We're thinking, okay, what's the square root of a squared? And the square root of a squared is a. So a and a go there and there. And what's the square root of b squared? It's b. B and b go there. If you want me to circle back here, so what's the square root of x squared is x and x. What's the square root of 64? 8. What's the square root of x squared? X. What's the square root of 100? 10. Okay, what's the square root of x? X. What's the square root of 16? 4. What's the square root of 4a squared? It's 2a. What's the square root of 9b squared? It's 3b. So I'm going to turn the page. I'm going to do a few more examples of difference of squares, and then we'll be done. So I'm going to just flip it. I think I'm on 5. And there we go. Okay, so if I gave you, now where this helps is problems like this. If I give you 16x squared minus 121. Because if I were to multiply, like split it up and put that 0x in there, 16 times 121 is a big number, and that's a lot to think about. So with this one, I prefer to like recognize, okay, there's 2 terms, they're subtracting, and they're both perfect squares. And so sometimes what I'll do is I'll rewrite these with their perfect squares. So what's the square root of 16? Well, we know it's 4. And what's the square root of x squared? Well, we know it's x. So it's like 4x squared. Sorry, the glare is like super bad. There we go. Okay, and then 121, what's the square root of 121? is 11. And so that allows me to know what my two terms are that I'm going to be like putting in my binomials. So when I factor, it's going to be 4x plus 11 and 4x minus 11. And that's that one. Okay, so I want you guys to try this one on your own using the shortcut. So let's try this. So we have 25x squared minus 81. So pause me here, try 6 on your own, and then come back and check your work. So you should be pausing me here. Okay, so I think what's the square root of 25x squared? Well, we know the square root of 25 is 5, and the square root of x squared is x. And then I think what's the square root of 81? It's 9. So I can split it into my two binomials, 5x minus 9 and 5x plus 9. And those are my two answers. It doesn't matter the order. It can be 5x plus 9 and then 5x minus 9, whichever one, like whatever order you do it in, that's totally fine. Okay, let's look at this one. What if I gave you x squared plus 25? Okay. So hopefully you're thinking to yourself, wait. There's something wrong here. You would be right? There's two terms. That's good. That checks the first box. They are both perfect squares. X squared is a perfect square. 25 is a perfect square. But what box does it not check? It doesn't check the subtracting. So what that means is this is not a difference of squares. So what that means is this is not factorable. Now, if you guys remember to the first video, when something is not factorable, we use the word prime. So again, prime, that's all that's saying is it's another word for saying not factorable. And that's that. Okay, we are just going to do one more. The last one is going to be something I kind of want you guys to see before, I want you guys to be aware of these. So, okay. So if I have 2x squared minus 50. Now you're thinking, great, there's two terms. Great, they're now subtracting. But wait, 2x squared and 50 they are not perfect squares. 2 is not a perfect square. 50 is not a perfect square. But if you remember from the last, our first unit that we did, or our first section that we did, factoring a GCF. We want to think about that always. That should always be kind of in the back of your head. And you can always think, is there a GCF that I can factor out first? And there is. What number goes evenly into both 2 and 50? And if you're yelling, 2, Mr. Imperio, you're right. So I can first factor that out, 2, and then I'm left with x squared, and then negative 50 divided by 2 is negative 25. And now, what do you notice about x squared minus 25? Well, x squared minus 25. X squared is now a perfect square. 25 is now a perfect square. So now we would keep factoring. So from here to here, all I did is I factored out a GCF. And honestly, that's something that I'm going to always encourage you guys. Always check for a GCF first. So this is our first time we have a GCF like in the problem, and we'll do some more of those also. But then we can factor our difference of squares. The square root of x squared is x. The square root of 25 is 5. So we'd keep going. Now we keep the 2 there, and it would be x plus 5 and x minus 5. And then that's my final answer. So if you then need to remind yourself, keep factoring the difference of squares. Like this is a 2-step factoring process, and some of the problems are going to be 2-step problems where you're factoring out a GCF and then you can factor it further. So I am actually going to do one more problem. I know you guys are like, I don't want to do one more problem, but you know what? You can't tell me no because, you're not here yelling at me. So now we can do one more problem. And I just want to show you a trinomial with a GCF in it. So we are going to we'll just do kind of a basic one here. So 2x squared minus 12x plus 18. Now, first, what we want to think about, okay, we could do the x method, and that's totally fine. You would still get to the same result. You would just have to factor out a GCF at the end. But if you look at 2, 12, and 18, you hopefully notice that they are all divisible by the same number. They're all divisible by 2. So I can factor out a 2, and I'm left with x squared minus 6x plus 9. So here you just did GCF first. And then this actually makes this problem really easy. You just use the x method. What multiplies together to get me 9 and adds to get me negative 6? Okay, we have either a positive times a positive to get me a positive, or a negative times a negative to get me a positive. Well, the only way that I'm going to add to get a negative is going to be a negative and a negative. And so what are my two numbers? Negative 3 and negative 3. Now, because I factored out the 2, a now on that x squared is 1, so I can go straight to the shortcut. It would be 2 times x minus 3 times x minus 3. And if we were writing that totally math appropriate, it would be 2 times x minus 3 squared. Okay, so that's it. We will do I'll make some more videos for reviewing. But that is it for new stuff today. I hope you guys have a great day. I hope you guys are keeping busy, doing something fun. I've been doing a puzzle, and the puzzle is killing me. But I love it. It keeps me super busy. So I hope you guys are finding, new fun things to do to kind of keep you busy. So have a great day, and I will see you guys later.